we're meeting this afternoon with Professor Benjamin Drake Wright of the University of Chicago. He is Professor of Education and Psychology and also a leading proponent of Rasch measurement. Ben, how did you come to arrive at the University of Chicago?
Well, it was 1947. I was a physicist working at the Bell Telephone Laboratories. I wanted to go to graduate school. Chicago had probably the greatest physics faculty in 1947-48 in the world. So I came here and studied physics for the rest of 47 and for most of 48. And then I realized that I didn't want to be a physicist the rest of my life. So I switched to human development. But after a couple of years of studying human development, I saw that the confusion in that area, in the social sciences, as to scientific research, and particularly quantitative scientific research, was immense. The statistics taught didn't work. The people who taught the statistics didn't understand the mathematics of what they were teaching. And I became very upset that I had made a terrible mistake in my career decision. But then I got involved. I had met Thurston, and I got interested in factor analysis. And for quite a long time, I thought that maybe factor analysis would be a way to improve the quantitative basis of social science research. That went on until, well, for 10 years, until in 1960, I met George Rasch. And at the time, I was working on what we called then a semantic differential. Those were 6-point rating scales, where subjects chose one of the categories to rate how good or bad, how strong or weak the object that they were describing was. I had done a great many factor analyses of more or less the same set of questions, and had discovered from sample to sample, even when we were describing the same things, the results differed too much to accept the idea that this was producing a stable set of numbers. So I was forced to back off from all of the details of the factor analysis and just say, well, this group of items will be the first dimension, and I'll weigh them all the same and pay no attention to any of the results of the factor analyses. And this other group will be the second, and so on and so forth. And I was suffering from that unsatisfactory state of affairs when I met George. And the first thing George and I did was to work together after his lectures on how to make a model for the semantic differential. So well, what I've now covered is how I got to Chicago and how I got to George.
When was George?
This is 1960, March 1960. And then I worked with him a great deal off and on throughout the 60s, and was fortunate enough to meet some students who were interested, and in particular, at that time, Bruce Chopin played a very important role in the development of my ideas. He reminded me of Newton's method for solving implicit equations. And as you know from the wonderful programs you've been writing, we still use that method. And it's very simple and very satisfactory in applying George Rasch's models to data. The next big event was in the 70s when we got interested in misfit. And Ronald Mead played a big part in the study of misfit. But we were still pretty much confined to dichotomies, to yes-no types of answers. And although George and I had begun in early 60s to try to work out a way to solve the rating scale problem, the solutions we came up with were too complicated and too laborious to apply. So we didn't get anywhere with that until David Andrich and then Jeff Masters got involved, at which point we saw suddenly, as we spoke about in the lesson that preceded the interview, that it could be very simply conceived and very simply engineered. And then something really nice happened to me in the 80s. I met you, Dr. John Linacre, and you saw that the additivity of this very simple model, it didn't have to be limited to a measure for a person and a calibration for an item and perhaps a difficulty for a step, but you could add as many linear terms as the situation seemed to justify, and that in fact the separability of parameters and the ease of estimating them would be just the same as it was for the dichotomy. So this led to your program facets, and has changed, actually, the application of Rasch methods from something fairly esoteric and rare to something anybody can do with a desktop PC-type computer, and one of the two programs that we put out. Facets, yours. Big Steps, now almost yours too, although originally from the earlier ones that I had written. And this leads me to introduce my friend here, Dr. John, otherwise known as Mike Linacre. Why don't you tell us why you're here? How did you get here?
Well, I came here, met up with Ben Wright as a result of a problem that, in fact, you haven't mentioned so far, a virtue of this methodology, and that is its amazing ability to be able to handle missing data. My own background is I went to Cambridge University in England, studied math and statistics, then got disinterested in the purity and remoteness that proper mathematicians are supposed to have, and drifted off ultimately into computer science. And I was in the position of maintaining a large database of test information that had been collected from Head Start program children in the early 1980s. And one of the problems with testing these young children was that there was a lot of missing data. We couldn't force the kids to answer every question no matter what we did. So the president of the company I was working for had the brilliant idea of going around and talking to all the leading test experts in the country to find out who had a solution to this problem. And only one did. And it was you, Ben. And that led to our meeting and to our composing together, mainly under your guidance, of the original PC Rasch computer program called Microscale. And Microscale had the virtue that it could handle missing data very flexibly, and also other response formats like rating scales. Ben, where do you see us going from here, though?
Well, see, the thing about the missing data, let me come back to that for a moment. There is never data that's complete. The idea that you have complete data is an illusion that people who ask 20 questions and happen to get 20 answers think they've got. But if they realize that the 20 questions are just a sample of the questions they might have asked, there's already missing data, the answer to all the questions that weren't asked. And as a matter of fact, we know from examining data more carefully with the programs that you have written, that you can show that in many cases a person may answer a question, but it might as well be missing data, because at that question they didn't function in the same way they had functioned on all the other questions. Either they were distracted, or they forgot, or they didn't pay attention, or something. And so there is often, as it were, invisible missing data, data that looks like it's there when it's not there. So the whole philosophy of inference requires you to be able to say something about the future based on the incomplete information you have from the past. So in a way, to be surprised that a computer program can deal with missing data reveals the naivete of the philosophy of the earlier approaches, that somehow you ought to have complete data and you ought to be sure to collect it and so on and so forth. In the beginning, it was difficult to use these methods, and it required quite a lot of persistence and often some sophistication. But as we have been able to understand the process more and more simply without losing any of its generality or implications, and as we've been able to make the computer programs more and more easy to use, including putting them in servers like the one that Yap, our friend from Singapore, is making, so that it makes them very easy to operate, the devices now are becoming available to use for thinking. Pedro Alvarez, our friend from Spain, the economics professor from Spain, says that for him, the Rasch model is a way to think about his problems. It organizes the problems. He never worries about such a thing as multidimensionality. He knows that everything is multidimensional. What he thinks about is, how can I sort this out so I can think about it in decisive ways? And that always means to establish single dimensions, along which the objects that he studied might be countries, might be cities, might be neighborhoods, might be wines, might be fruits, might be companies. The objects that he studied, to put them on a line so that he can compare them. Because the word comparison contains in it the implication that there is one dimension on which you're going to compare the two things. You can't say, well, you're taller, but I'm heavier. So what's the comparison? There's only a comparison if we've already implied that there's only one thing we're talking about right now, and you have more of it and I have less of it. It, just one it. If they're two, we've lost the comparison. They're two different its that we're talking about, and we haven't got them sorted out. And I do think that it's going to become used not just by educational researchers, but by scientists in every area, science, biology, medicine, wherever, to organize their thinking. I think it will eventually become used by stockbrokers to analyze their trading and to analyze the areas of the market that they're interested in. I think it will be used by economists and by businesses to manage inventory and the flow of goods, because it's such a tidy, decisive, and clearly speaking way of organizing information.
So it sounds then that the future is in the application, not in increased mathematical sophistication or statistical niceties.
No, I don't think. I think anybody who thinks through the basic ideas realizes that they are getting simpler all the time, not more complicated, and that mathematical complications have nothing to offer this particular field. It's like trying to improve the gasoline engine. You really can't improve it much anymore. It is the way it is. You can fiddle around with it, but the important consequence of the gasoline engine is the automobile and the truck and all the things you do with automobiles and trucks. And the actual engine has hardly changed at all in decades. The details of its change are quite inconsequential almost.
Then what are the big improvements that you can see coming in
applications and visualization? I mean, we know that the mind's ability to analyze complexities depends on visualization. And visualization means making a picture, a plot. And a picture loses its meaning if the dimensions of the picture are not under control, can't be held steady. If the plots can't be made to look the same in the frame of reference so that you can see if things have gotten bigger or smaller, if they've moved to the left or the right, this requires the same units. And I think as we learn better and better ways to make the results of the analysis visualizable to the analyst in process, kind of online visualization, the more it will become a thinking tool, and that what will finally appear in the reports will just be the last couple of pictures. The analyst may look at many pictures, stepwise pictures, working his way through the possibilities and the alternatives, but with the support of a fixed frame of reference, he'll be able to decide very quickly what's happening, which way to go, where the patterns are, where the misfits are, the exceptions, and then eventually his report will come out with the frame of reference and its definition, and then the case studies of the misfits that have been diagnosed constructively.
Have you any examples of how use of Rasch techniques have led to different substantive outcomes, to more traditional approaches, more conventional approaches?
Well, not any particular examples, I guess.
I was thinking maybe in the medical field we encountered an interesting situation where ceiling and floor effects were being misunderstood.
Oh, yes, yes. You tell that story.
Well, one of the major recent areas where Rasch methods have become more prevalent, in fact are spreading very quickly right as we speak, is in the area of medical research and the discovery of how well patients are performing, and for instance in therapy and rehabilitation. And here for a long time they had noticed that when you got towards the end of therapy, patients seemed to stop improving according to the raw scores that they were using. Or at the beginning of therapy, it seemed to take a long time for the patients to start improving, again according to the raw scores from the observation instruments that were being applied. So they were saying that these were ceiling and floor effects in the therapy. Well, in fact, one of the earliest discoveries that Ben and I made in this research was that these ceiling and floor effects weren't in the therapy at all, but were in fact in the raw scores that were being used. As soon as the raw scores were converted to linear measures, it became clear that patients improved right from the beginning of therapy, and in fact, were still improving at a steady rate when therapy was stopped. In fact, one of the practical implications was that patients were probably being sent home too soon. They were being sent home when the therapy was still working. In other words, someone might be sent home in a wheelchair, when in fact, if they had continued on the therapy a little longer, the patient would have walked out the door. So here was a practical effect of the non-linear, uncontrolled way that raw scores behave when compared to the well-controlled and clear way that linear measures behave.
The tragedy was that the therapists were misunderstanding the potency of their rehabilitation programs, and the patients were being deprived of the additional therapy which would have helped them because of a misunderstanding of the numerical indications of what was happening. The misunderstanding that at the top of a test, the one more right answer means much more than in the middle of the test. And it was the score ogive that you can draw so easily, which shows the misinterpretation. There's something else interesting that you reminded me of. Carl Granger has just a short list of pain questions he asks people. He deals with people whose pain is differently originated, sometimes in a bad back, sometimes in a shoulder or an arm. He found that when he calibrated his pain items, they calibrated differently for back pain and shoulder pain, let us say. He wasn't surprised because the kind of things you can or cannot do are different if your pain is in your lower back or if it's in your shoulders. So he didn't really expect that he would define the same yardstick for both kinds of pain. He was perfectly content to have a lower back yardstick and a shoulder yardstick. But what he discovered was he could give his questionnaire to patients in the waiting room, have his assistant run it through the program, find out which set of calibrations that patient's answers fit best, and that was very often an adequate diagnosis of where the source of pain was. Now, he would have found out through his medical examination eventually, but this didn't take any time at all. It's a 10-minute questionnaire to fill out, and by comparing it to two different definitions of increasing pain, he's able to get a preliminary screening that cost him nothing before he starts his physical examination, which most of the time is accurate. So there is this diagnostic aspect to it in addition to the measuring one.
So this seems to be an example that to, say, treat different types of pain as multidimensional would in fact have, in the original analysis, would have lost him the ability to diagnose the difference later on.
Absolutely. Had he kept this mixed up, he could never have used it to discriminate. Yes. Something else apropos of that is that functional independence measure which they used. It was originally designed by an international committee to have 18 items, and it was used with a single 7-point scale for each item, and you added it up, and the total score was your measure of functional independence. However, when we got the job of analyzing it, we discovered almost immediately that 5 of the items were different. 13 were measuring one kind of thing, and the other 5 were measuring something else. We could not get them to work together. When we looked at the content of the items, what was amazing was that the International Committee had not foreseen this, because the 5 items were all about cognitive function, and the 13 items were all about motor function. And everybody, I think, would know that those are different things, and that rehabilitation of the body may not, in fact, affect the mind yet, or as rapidly, and that sometimes rehabilitation of the mind doesn't have much effect on physical functioning. But they had lived with this confusion of these two seemingly clearly distinct considerations for some years, and worked with one score which mixed up these two components. And in our analysis with the Rasch programs, we were forced by the misfit and by what happened when we compared admission and discharge measures, we were forced to separate the items into these two groups, quite on the basis of the abstract numbers. We made the first part before we knew what the names of the items were. And of course, once we saw the names of the items, it seemed overwhelming that it should be this way. In fact, thinking back, we would have wondered how it could not have been this way. But the moral of that story is that the men who chose these 18 items were not fools. They were the best in the world. But they missed the distinction between the two types of items. But our analysis immediately cleared that up and made it obvious to them, and brought to them the value of making 2 measures for each person and not 1.
But there's a growing trend now to move from multiple choice testing to performance assessment. Does this make Rasch measurement more or less relevant? Is Rasch measurement going to go obsolete, or is it in fact going to become essentially the only way to do things?
Well, you might well ask Dr. Linacre, author of the many-facet Rasch measurement book and the facets program, because Mike didn't really plan on doing this. He really wanted to do something else. But we had some clients in medical technology who were colleagues, really, I guess not clients, who were rating performances by medical technologists and were very suspicious of the quality of the judges they were using to do this. They observed that the judges were not equal, that no matter how they trained them, they didn't function the same way. And so he said, can't you do something to help us? So Mike finally said, okay, I'll write a PhD thesis and get a PhD just to help you with this problem. And he devised facets so that the judges could be calibrated. And one of the first things we discovered in looking at their data is that in some cases, there was more difference between the judges than there was between the candidates. That is, the candidates were all quite well trained and quite competent at performing making the slides, for example, that they were instructed to make. Whereas the pathologists who graded the slides by looking at them through the microscope were very different in the standards that they set for a good slide. So the pathologists spread way out, and the clinicians, the candidates for licensing, were quite compact. But that was not visible in the raw scores because the raw scores spread out too, not because the candidates differed, but because the pathologists who judged the slides differed. So there was a gross misunderstanding of what was happening there. The most able candidate, if he had a severe judge, could fail, and the most unable candidate, if he had a permissive judge, could pass. In other words, it was chaos. What was intended to license these practitioners to keep their jobs or to force them back into more training was just haphazard because of the lack of control of the judges, the pathologist raters. And the only program that does this successfully is facets. There are other approaches to this, but they work in the wrong direction. The other approach says, well, you can't just have the variance of the candidates. You've also got the variance of the judges. So that means that you know even less about what's happening than you thought you did. But Mike's facets program takes it the other way. It says, let's estimate the severity of the judges, and let's remove it so that you know better what you want. Not worse, but better. The standard error of the measures of the candidates, when corrected for the judge severity, are smaller than when the judge severity is left in. So the generalizability approach increases the confusion. The facets approach decreases it. There's no doubt in my mind that all of those analysis of variance type approaches, particularly when they're applied to raw scores, will soon disappear from practice. They may continue in university departments, I don't know, because university professors do all kinds of silly things to keep their jobs or to keep themselves entertained. But in actual practice, where people's careers matter, where legal issues come up, you've got to demonstrate your fairness. The only way that an analyst can do that satisfactorily is with the kind of partition that Mike does with his facets program. So I think what's going to happen is that program you've created is going to soon be taken for granted as the only way to do this kind of thing. And people will think they always did it that way. And you'll become a has-been because they'll assume that all you did was what everybody knew already.
An interesting sidelight on that medical application was that the judges there were in fact very well trained.
Oh, they were professors of pathology at universities.
And now, of course, with the performance assessment they're thinking of in schools, and some states are already trying to put into effect, the judge training is minimal. In fact, they're talking about having the parents, the other students in the class, and everybody else rate the work, in which case the differences between the judges will become absolutely decisive of what's going on.
The important thing about facets is, and it does for the judges just what it does for the items and the persons. In the judge's case, it extracts the typical severity or leniency of the judge so that you can remove that from the score, leaving the ability of the candidate behind. But it also analyzes the judge's consistency and coherence. And if the judge is unable to provide consistent judgments, this sticks out like a sore thumb in the data analysis, you have a chance to protect the children from being misunderstood, misrepresented by judges who are not qualified to make judgments. And this you find out as you go. You don't find out some other time when it's too late. You find out at the moment that you analyze the data. And this is very important. I think that's another change that's going to happen. In so much of the application of statistics in social science, the statistics is done months, years later. It's reported decades later. It never has any constructive effect on the victims of the data collection. Whereas in the way we're applying facets, it's so easy to apply that you apply it every week as the data comes in. And as the data comes in and you apply it and you see things are going wrong, you intervene constructively in time so that the participants aren't mistreated by the inadequacies of your data analysis. And I think what's going to happen is statistics is going to become au courant, online. Yeah. You're going to do it at the end of each day almost, and keep updating the analysis and intervening, changing the plan, changing the questionnaire, changing the sampling, as you see, changing the judges, as you see that they're not producing the quality that you want to have. And so the whole research process, the whole evaluation process will become alive. It'll be a dynamic process, not a static once a year, reported 6 months later when nobody cares anymore kind of activity that it is now.
In fact, I think that flexibility is going to be decisive as well in the performance assessment, because now the child can choose which task he wants to do.
Yes.
He doesn't have to do the same task as everybody else, or the one that the statistical judging plan says, this is the one that the children in this classroom have to do. He can just choose the task that suits him or her and then be rated on it. And so the judging no longer becomes intrusive, but in fact maybe even exciting.
As a matter of fact, that is the humane approach. Do what you're good at. Instead of saying, our measurement plan requires you to do this thing, whether you like it or not, whether you're good at it or not, this says to a child, do the thing you're good at, and we will try to measure your ability from that. Makes much more sense. But it requires a calibration system of the kind that FACET constructs and maintains in order to be able to do it.
That's right. Indeed, I think the state of Georgia are trying to build an item bank, but also a judge bank, so that once someone has been rating for a while, one knows their severity, their characteristics in just the same way that one would of, say, an item, test item. Ben, are there any other exciting new areas where you think Rasch will be applied, apart from the educational and medical areas?
Well, almost everywhere. Here we should 5 minutes. Here we should get Pedro to talk, because Pedro is finding every conceivable area of application, and I won't do him justice by trying to give a list, but I know he has applied it to pollution problems, to wine manufacturing problems, to wine tasting judges, to advertising, to the effects of newspapers on public opinion, to quality of life in different countries, to the effects of traffic on the quality of a neighborhood that you live in. And I also know anthropologists who've used it, and archaeologists have used it, and paleontologists have used it, and civil engineers dealing with highway maintenance in Sweden have used it. So, and people running prisons have used it to manage the delinquencies of the prisoners, to try to find out. See, in a prison, a prisoner may get into trouble because he is provoked by the situation, or he may get into trouble because he's a bad person. Well, so they move the prisoners around to different places, and if he keeps on getting into trouble, is it because he's a bad person or because he keeps being put into a provocative situation? So for that, you need to separate out what's the prisoner and what's the situation in order to decide how to manage the penitentiary. And it's been used in that situation successfully. So I don't think there's any situation where you're thinking where it can't be useful.
Well, that's encouraging. I was noticing during your presentation you were talking about the data as concrete and the what it means as abstract, and yet it seemed that you believed the abstract more than the concrete.
Absolutely. That is, I believe what I think, not what happened to me. The concrete is what has happened to me, and it's my job to think about it, figure out what it means, and believe that, and not just be stuck on what happened. Because it's never going to happen again. It happened. It's over. It's gone.
Does that mean we shouldn't give credit to children for lucky guesses on their multiple choice test?
How do we know whether they're lucky guesses or not? I don't know. Tell me why you asked me that question.
Well, of course, the child basically scored at a low level, but happened to get the hardest item right. And we can hardly believe this really reflects the child's ability.
Oh, I see what you mean.
But of course, we want to be fair to the child.
I see. So in constructing the meaning of the child's performance, if there is an unexpected right answer, I must ask myself, what is its meaning? And its meaning may be different than the meaning of the other answers. In which case, I would not believe it told me about the child's ability. I might ask him the question again to make sure that it was just a lucky guess, or I might ask him some other questions along the same lines to verify the interpretation. But if I didn't have time to do that, I probably would set that aside as an accident.
It sounds, though, that you don't parameterize it as part of the item, then.
No, that's not what I'm looking for. I'm not trying to measure guessing. I'm trying to measure knowledge of the subject matter of the items. So if I see evidence, if I see an event for which the easiest interpretation is that it was a lucky guess, the best thing to do is to remove it from the analysis, not to figure out how to have a parameter to disguise it so it won't look like it's a lucky guess. Right.
In looking back over your career, what would you say was your greatest accomplishment? Could you summarize it?
My greatest accomplishment, making things simpler. I really like to make things simple and useful. And I get very angry at colleagues who want to make them more complicated and useful and less useful. That I really think things have got to be simple, and that's what I care about.
Well, thank you very much, Professor Wright, for meeting with us this afternoon.
Thank you, Mike, dear friend and colleague.